So in this video I want to explore a particular idealized iteration in a circle. I'm going to designate 3 points O1, O2, and O3 in the interior of the circle. I'm going to make O2 and O3 be reflections of each other with respect to the center. And O1 I'm going to be able to set manually here to some position, some desired position. And the question I want to ask in this video is there a particular position for O1 such that if I do this kind of iteration, I'm going to go through O1 from P1. I'm going to start from P1, go through O1, meet P2, and I'm going to repeat this chord construction through O2, then through O3, and then I'm going to keep repeating this in round-robin fashion. I'm going to do this 9 times. So here's the 4th, just went through O1. Here's the 5th, the 6th, the 7th, the 8th, and the 9th. Now, after I do 9 iterations, I'm going to end up at a vertex P10. And what I want to ask in this video is if there's a position for O1 such that P10 can be brought to P1. So let's now manually move O1 around. Actually, I'm going the wrong direction, so let's go over here. And it looks like if O1 is around this location here, I can nudge O1 just ever so slightly. Oops, this was too strong. I can nudge it manually so that now P1 and P10 are approximately the same point. Okay? Now a miracle happens. Now if I slide P1 anywhere on the black circle, I maintain closure. Okay? Now speaking with Arseny Akopian, he told me this is a known result, and actually that this closure and this porism is exact. Okay, so there are choices of O1 such that, so let me say it this way, if you choose an O1 such that you close this 9 gon, it's going to be perfectly closed for all P1. So it's an exact and not quasi-porism that I'm achieving here. Now, I can internally do this optimization and find the exact O1, not in a manual way, but that would actually make P1 and P10 be identical. And I can take this thing one step further. I can ask the following question. What's the locus of O1 such that I can close a 9-gon porism? And it turns out, and this could be a new result, that the locus of O1, when O2 and O3 are reflections of each other with respect to the center of the circle, the locus of O1 is a perfect ellipse. So I'm drawing this green ellipse here. I'm showing its foci. And you guys can see that as I slide O1 through the green ellipse, okay, I maintain P1 and P10 co-located. And in fact, now if I do the P1 slide, you can see here that for that particular one, I maintain the porism. Okay? Now, one thing that I notice here, besides the fact that the locus of O1 is an ellipse, is the fact that when I slide O1, 2 edges of the induced 9-gon are going to remain stationary. So what I'm going to do here is I'm going to just do a very slow sliding of O1 on this purported elliptic locus that keeps the closure alive, right? And I want you to notice that there are 2 edges of this trajectory, namely P8 to P9 and P9 to P10 or P9 back to P1, which remain stationary. Now this could be an approximation. It is true though that since P1 and P10 are co-located, okay, and the very last iteration is through O3, this, if you backtrack and you go P10 back to P9, since O3 is fixed, this edge has to be stationary. Likewise, since O2 is fixed, P9 backtracking to P8 has to be stationary. Okay, but everything else is moving. So you have 2 edges here that sort of as a corollary must remain stationary if O1 is actually sliding on a curve that maintains closure. Okay, now so that we see this from a different P1 position. Let's go ahead and just slide P1 here to another position, P1 and P10. Let's slide it over here, and let's continue the O1 slide. So again, P8, P9, P9, P10, since O2 and O3 are fixed, remain stationary, but all the other edges of the trajectory are moving. Now, if I pick a particular O1 like this one, and now I slide P1, you're going to see that all edges will be moving. So this is the actual porism that is happening with O1 fixed. You can shift O1 to some other place on that green ellipse and then maintain the porism. Okay guys, so this is a phenomenon. I'll see you on the next video.